In this video, I'm going to be solving inequalities. In fact, linear inequalities. And so notice what it says here at the top. And actually, before I even read that, I would just tell you that in order to be successful here, you have to be comfortable solving equations. That's why we took some time to make sure you have a good foundation for solving equations. So if you're struggling in that area, you may want to do a little review before you get into this section. In solving inequalities, it's going to be a lot like solving equations, but it's a little bit different. So let me show you how. So if I had 2x equals 5, then if I divide both sides by 2, I get x equals 5 halves. And 5 halves is the solution. Now if I had 2x equal, or as we'll say is less than 6, then if I divide each side by 2, I would get x is less than 3. So notice the solution here, like the one we just did, has one solution, whereas here when we solve this, what we call an inequality, x is less than 3 actually represents a set of infinitely many numbers. There's no limit to the amount of numbers that are less than 3. And so we've got to have a good way of describing sets of numbers, because especially when we solve inequalities, we're going to have infinite solution sets. All right, so let's go ahead and look at our directions here. Let me go ahead and erase this stuff here. So solving inequalities, we do that just like equations with the following exceptions. Number one, when multiplying or dividing on each side by a negative number, we must reverse the direction of the inequality, or the inequality symbol. So that's key, when multiplying or dividing on each side by a negative number. So it's only when we do multiplication or division when we're using our equation solving skills, and it's always only when it's division or multiplication by a negative number. That's the only time we change the symbol. So just remember that. Be careful. You don't want to be switching the symbol constantly. This is the only time we do. In a regular problem, normally you're going to switch that symbol one time, and that's only if you divide or multiply each side by a negative. And then number two, it's what I was talking about just a minute ago. Our solutions will be infinite set of numbers, or sets of numbers, which we can describe using interval notation or by graphing on the number line. All right, so I've given you several examples here. So I want you to look at example 1. So notice we had negative 2x greater than 5. Notice I divided each side by negative 2. And because I'm dividing by a negative number, notice I reversed the symbol. Look at number 2. I had to subtract 4 on both sides. Notice I didn't reverse the symbol, because I only reverse the symbol when I multiply or divide each side, by a negative number. And so you get x is greater than negative 6. Notice on number 3, I multiplied by the reciprocal here, and that was a negative number, and so you'll notice I went from less than to greater than, or less than or equal to greater than or equal. All right, so look at number 4. So in the first method, using method 1 here, I subtracted 5x from both sides, and then I added 1 to both sides. I divided by 3, or negative 3 on both sides, and notice that's where I reversed the symbol. It's only when I got to the point where I divided by a negative. Now the other way to, now I'll just give you a tip. When I solve these types of inequalities, I normally keep x on the left, and it helps me avoid this one little issue that we're going to talk about. What if you decide you want to keep x on the right? Well, in that case, I would have subtracted 2x on both sides, which I did here, and you end up with this equation here. And then I'm trying to get x by itself on the right. So I subtracted 8 from each side, and then I divided by 3 here, and notice I'm dividing by a positive, so the symbol didn't change, and so I end up with this here. Now when we were talking about equations, I told you I don't care which side you put x on. But when you're dealing with inequalities, x needs to be on the left. What I found out in the past is students often didn't know what their answer meant when they got an answer like this one here. And so by putting the x on the left, you're showing me that you do know what that indicates or what it means. When you, hold on a sec, when you read this backwards, it is read x is less than -3, which is how you say this. So basically switching the x and switching the direction of the sign straighten things out. But if you keep your x on the left, you won't have to worry about that concern. Now you might want to do copy down number 5 and maybe see if you can do that one all the way through and then check your work. Now the other thing I wanted to do while we're here is give you some practice with writing answers in interval notation. So I would encourage you to do problems 1 through 4 and see if you can write each of those using interval notation. And I would encourage you to consider doing the graph first, and then you can use the graph to help you write the interval notation. Now eventually you want to get to the point where you can just write out the interval notation. All right, so so hopefully you stopped the video and you got your answers. Let's see how you did. On number 1, x is less than -5/2. The graph would look like that. And going from left to right, you have -infinity to -5/2. And that is a parenthesis there because it's not less than or equal, it's just less than. So it's the numbers less than -5/2. On number 2, you had x is greater than -6. There's your graph. And going from left to right, you have -6 to infinity. Again, you always put the smaller number on the left and the bigger number on the right. Number 3, you have x is greater or equal to -6. So in fact, the graph is just like this one, except you would have a bracket here instead. And so in interval notation, it would look like that. The quantity -6 to infinity, where the -6 has a bracket. And then finally, on number 4, you have x is less than -3. The graph would look like that. That's all the numbers less than -3. So again, parenthesis here. And going from left to right, that would be -infinity to -3. All right, on number 5 through 9, you're going to be solving each of these, and then you're going to graph your solution on a number line. Now, if you think you've got the idea based from looking at the examples, I would encourage you to go ahead and try to solve these. I mean, you want to just watch the video, that's fine too. But I always will encourage you, once you think you got the concept down, to practice, and then I'll give you feedback. At least that's my plan. All right, so let's see how you did. On number 5, this is basically like a two-step equation. The only difference is the inequality. So we know with two-step equations, we always add or subtract on both sides first. So let's subtract 5 on each side. On the left, you get 2x, and on the right, you're going to get -11. You know what, I'm going to change colors here. All right, so now we need to get rid of that 2. We're going to divide by 2 on each side. We get x is less than -11/2, and your graph will look like that. Notice that is a parenthesis, maybe not a very good one, but that is a parenthesis. All right, on number 6, you see you have minus x over 2. You have x divided by 2, or you could even think, you can put that negative in the numerator or the denominator, but not both. So think of it as x over -2. If you multiply each side by -2, well, on the left, these -2's are going to cancel, and you're going to have x on the right. -6 times -2 is 12. So we do have x is less than or equal to 12. Notice I reversed the symbol because we multiplied by a negative on both sides. So when we graph that, that's going to look like that. We have a negative infinity until we get to 12, and there's a bracket. All right, number 7, this is also a two-step inequality. I've got to subtract 8, and I'm going to have to divide by -2. We know we always add or subtract first. So let's subtract 8 on both sides. We get -2x is less than or equal to 2. And then we'll divide by -2 on both sides. We get x. Now notice we're going to reverse the symbol because we divided by a negative on both sides. So we get x is greater or equal to -1. And so our graph goes from -1 to infinity, where we have a bracket at -1. All right, on number 8, I am going to, it looks like on the left side there's nothing to do. 3x and 11 are not like terms. But on the right, we have some simplifying to do. So I just want to remind you really what I'm doing here is what I called CSI. I don't have any fractions to clear, at least not yet. I'm simplifying the right side here. And then remember, I is for isolate. If we have to get x on one side, then we'll do that step. And then once we've done those 3 things, CSI, we should have a 1 or 2 step equation. All right, so we're going to get 5x minus 15 when we distribute there. Don't forget to bring down your -4. Notice the 5 does not get distributed times the -4. It's not inside the parentheses. Now we're not quite simplified on the right. We still have these 2 like terms here. So let's go ahead and simplify that. -15 and -4 is -19. And so now we've simplified. We need to isolate x on one side. And so I'm going to go ahead and get rid of the 5x on the right. And so let's subtract 5x on both sides. And when you do that, you'll get -2x. 3x and a -5x is -2x. -11 is greater or equal to -19. So now we've done some simplifying. We've isolated x on one side. And so we've got our 2-step equation. You should have added 11 to both sides. You get -2x is greater or equal to -8. And again, I have not reversed the symbol so far because so far I have not done any division and certainly haven't by a negative, but here I will. So I'm going to divide both sides by -2, and so my symbol is going to be reversed, and we get x is less than or equal to 4. And our graph would look like that. -infinity up to 4, where you have a bracket at 4. Okay, so now we're at our fraction problem. This will be good practice for you, especially if you've struggled working with fractions. So hopefully the first thing you did here is you found the LCD, which is 4. Remember the multiples of 2, that'd be 2, 4, 6, 8. The multiples of 4, 4, 8, and so on. Notice 4 is a multiple of 2, and so 4 is the least common multiple, or the LCD of the denominators. So we're going to multiply each term on both sides of the inequality by 4. Now, with the 4 and the 2, 4 divided by 2 is 2, and we're multiplying 2 times -1x, that's -2x. 4 times 4 is 16. Don't forget, you got to multiply all the terms by 4, not just the fractions. All right, on the other side, we're going to cancel the 4's here, and we'll get 1 times 3x, which is 3x, and then 2 times 4, we're going to get -8. And so notice, if we're doing CSI here, we cleared fractions, and now we have a, actually, you know what, we are not to a 1 or 2 step equation. There's no simplifying to do, but we do have some isolating to do. We do have x on both sides. So again, you could add 2x to both sides. I prefer to keep my x on the left, so I'm going to go ahead and subtract 3x on both sides. You get -5x plus 16 is less than -8. And then I'm going to subtract 16 on both sides, because this is a 2-step inequality here. and we get negative 5x is less than negative 24. And we're going to go ahead and divide each side by negative 5. Oh, we divided by a negative, so actually I think I did that already. So we get x is greater than 24/5. And when you graph that, it looks like that. We're going to have a parenthesis at 24/5, and then we'll shade everything to the right of that. All right, we got one last problem to do here. So it says Martha's taking a math course and she's earned scores of 94, 90, and 78 on the first 3 tests. What scores on the 4th test will get her test average to a 90 so that she can earn an A? So that last score, that 78, kind of hurt. Before that, she was doing pretty well. So she's going to have to bring this average up in order to have a 90% average or an A average. So think about, well, first of all, we have to find the 4th test score so that she gets she gets a 90 or better overall, 90 or better average. So first of all, x is going to equal the 4th test score. Now think about how you do average. I think most students are pretty familiar with average. If you want to find the average of 4 numbers, you add up the 4 numbers and you divide by how many there are. All right, so in this case, 94 plus 90 plus 78 plus x, that's my 4th score. And if I divide that by 4, I want that to be 90. Now notice it says what scores on the 4th test. So anything that's going to make her either equal to 90 or her average equal to 90 or greater. And so we're using greater or equal to 90. We want this average to be greater or equal to 90. So the first thing I hope you see here, and by the way, I would encourage you to see if you can solve this inequality yourself and then check my answer. All right, so let's see how you did. So first of all, I would hope that you want to get rid of the fraction. We want to clear fractions first. And so we'll multiply each side by 4. Since there is only one denominator, and it is 4, so our 4's cancel on the left, and we're left with 94 plus 90 plus 78 plus x is greater or equal to 360. Oops, I forgot my greater or equal symbol there. Okay, so now I've got some like terms here. I can combine these numbers. I get 262 plus x is greater or equal to 360. I forgot my greater or equal. And then finally, I'm trying to get x by itself, so I need to get rid of that 262. And so we're going to get x is greater or equal to 98. So what does that mean? Well, first of all, it's like, oh shoot, she's got to do better on this 4th test than any other test in order to get that A average. So Martha kind of put herself in a little bit of a bad spot here. But the bottom line is a score of 98 or better will get her to an average of 90. Hopefully she's done really well on her homework and quizzes, and so maybe she can do a little lower than that and still be okay. All right, that's it for this video.